Today we're going to talk about solving one-step equations. To solve an equation means to find the value of the variable that makes the equation true. In other words, if you're trying to solve an equation, you just want to get the variable by itself. So let's take a look at a few examples. In our first example, I often encourage people to put a line right through the equal sign so you can very clearly tell the two sides of the equation. On the left side we have c minus 22. On the right side we have 54. Now remember, our goal is to get the variable by itself. In this case, the variable, or the only letter we can find in the entire equation, is the letter c, the variable c. Then we have a negative 22, and we have a 54 on the other side. We're trying to isolate the c. We're trying to get c all by itself. And to do that, we need to get rid of subtract 22. The way we're going to accomplish that is by doing the opposite of subtract 22. We will add 22. And what you do to one side of the equation, you have to do to the other side of the equation. So on the left side, the 22's cancel, and I'm left with just c. On the right side, what I have here are two like terms, 54 and 22. They're both constants, and I can put those together as we learned in step 3. We learned that we can combine like terms. When I combine these, I get 76. So now I check, is my variable all by itself? Have I isolated the variable? I have. C is all alone on the left side of the equation, and it equals 76. Therefore, that becomes my answer. Put a box around it. We'll try the next example. Again, I'm going to put a red line down the center. And you might say, well, these problems are pretty easy. They are right now, but they're going to step up in difficulty rather quickly. And if you have good habits and strategies in place while you're working on the simpler problems, the more difficult problems will make a little bit more sense. I have a J. I have negative 87. I have negative 3. We're trying to solve, which means we want to get J by itself. That's the variable. To do that, we're going to add 87 to both sides. The 87s cancel out. Negative 87, positive 87 cancel out. J equals 84. Let's try a third one. Again, I'll put my line down the center, so I remember that I have two sides of an equation. G is my variable, negative 25 is another term, and 113 is the last term. I want to get G all by itself over here. Currently, we have negative 25 keeping it company, so I'm going to add 25. I'm left with just G, and that's going to equal 138. Often people don't like the variable to be left on the right side of the equation. That's fine. You're allowed to switch them. You could put G equals 138 if you prefer. It means the same thing. Both answers are acceptable. Both answers are correct. Let's look at a different example. Notice this says solve by subtracting. When I look at my variable, m, I also have a 63 and a 79. If I were to simply add 63 on both sides, the 63's would not cancel out. 63 and 63 does not cancel out to a 0. I need to subtract 63 from both sides because this is really a positive 63. When you don't have a symbol there, remember that's a positive. So if I subtract 63 on both sides, they will cancel out. I will be left with m equals 16. Let's skip over to the third example under subtraction. Again, I have a variable p, I have a variable 16, and I have a variable negative 12. In order to isolate the p, I need to do the opposite of add 16. I need to subtract 16 from both sides. I'm left with p on the right side, and on the left side I have negative 28. And again, you could flip that over so that you have p equals negative 28 for your final answer. Or you could leave it just like this. Either answer is acceptable. Sometimes we don't need to solve by adding or subtracting. Sometimes we need to solve by multiplying or dividing. For example, I'm going to highlight just the variable. And then I have a 5 right next to the variable that I'm trying to isolate. I'm trying to get w by itself. W is not by itself because of this pesky 5. So I say to myself, well, how is the 5 connected to the w? Is it added to the w? No, it's not subtracted. When two numbers are touching like this, that means times. We learned that a few steps ago. So in order to do the inverse of multiplication, I'm going to divide both sides by 5. On the left, the 5's cancel out, leaving me with a w. And on the right side, 15 divided by 5 is 3. Going to try to do a little bit less highlighting this time because I think you're getting the idea. I'm trying to get the x by itself. I currently have 2x, which means 2 times x. How do we undo multiplication? We do the inverse. We divide by 2. So I'm left with x equals negative 14. How about this example? X is on the left side of the equation. How is this 7 connected to the x? Well, if you notice, this symbol right here is our division symbol. What's the inverse of division? It's multiplication. So I want to multiply both sides by 7. If I do times 7 on the left, I'm going to do times 7 on the right. On the left, multiplying and dividing by 7 cancel out. We're left with x equals negative 35. Similarly, I highlight the variable. I show two sides of the equation. N divided by 9. I want to do the inverse, which is to multiply by 9. If I do it on the left, I do it on the right. The 9's cancel out. N equals 9. Now the last example is when we have a fraction with a variable. There's lots of different approaches to how to best solve an equation like this. I'm going to show you to just flip the fraction. Let's write that out. Flip the fraction. Whenever you see a fraction with a numerator and a denominator, let's just flip the fraction. On the left, let me highlight my variable so you can see the letter, the variable y we're trying to get by itself. It's not by itself though because of this 2/3. So what I'm going to do is flip the fraction and multiply. Do you see how the 2's will cancel out and the 3's will cancel out? And that's our goal. We want to cancel these so that we're left with just y. But remember, if I do this on the left side, I also do the same thing on the right side. And I multiply and get negative 27. So flipping the fraction will cancel out the fraction you see. Let's try one last one. What do you think we should multiply by when I flip this fraction? I end up multiplying by 5/3 on both sides. I'm going to turn that into a fraction because it's easier to multiply two numbers that are both fractions. The 3's are canceled, the 5's are canceled. I'm left with k equals 10.